Welcome. Now we are going to see expectation of a random variable. Okay, whenever we perform some random experiment, we expect something to happen. Okay, and that expectation should be something average, right? So if we expect something more, that may not happen. So basically, this expectation of random variables means on an average what can we expect. That is known as expectation of a random variable. Okay, so this expectation is defined as, it is denoted as e of x. In the case of continuous random variable, it is integral over whatsoever the given limits is x times of f of x dx. Okay, if it is a discrete random variable, it is summation x mass function. That's it. Okay, what we are actually doing here, see, if you notice, it is kind of finding an average, isn't it? Okay, so that is the mean. If you come here, suppose we say, okay, suppose given these three values, find an average or mean of it. How do we do it? Mean is we just make the sum and divided by 3, since we have 3 entries, right? So this is how we were finding the mean. Why do we divide it by 3? Because here, if you notice, it has, like, out of these three values, we have 1 upon 3 chances for one to be chosen. The same for other two things. Suppose we have like this, and we are doing this, then we just divide it by 4 and add 2 and find out the average, isn't it? Okay, but let me tell you something different from this. Here we have four values. Out of these four values, the chances for choosing that one is 1 upon 4. The chances for choosing 2 is what? 2 upon 4. Chances for choosing 3 is 1 upon 4. Now you come here. It is 1 multiplied with 1 upon 4 plus 2 multiplied with 2 upon 4 plus 3 multiplied with 1 upon 4. It 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 comes as what? It is simply 8 upon 4, which is 2. So actually this is what we are doing. Okay. So if you come back here, what is happening? Associated with all the possibilities in the case of discrete random variable, we have a probability associated with all these values. We just multiply the corresponding things and sum them up. It is the average or expectation. Okay, the same thing we are doing. So for each along with each possible values, we are multiplying the density and we are integrating in the case of continuous random variable. So this expectation of a random variable is this one, and expectation is the same as that of the mean. Okay, mean is denoted as mu, which is nothing but expectation of x. Okay, now, not expectation of a random variable. If x is a random variable, x per n is also a random variable. Okay, so to calculate the moments, we need this definition, that is expectation of x per n, that is integral minus infinity to infinity x per n f of x dx in the case of continuous random variable. In the case of discrete random variable, what will we have? It is summation x power n p of x. Okay, and variance, mean is denoted as mu, and variance is denoted as variance of x, or sometimes sigma square, which is nothing but expectation of x square minus expectation of x square, that is expectation of x square minus mu square. Okay, and the sigma square is variance, and sigma is known as standard deviation. Okay, what does this mean and standard deviation measure? Suppose, okay, this probabilistic situation results in something, right? Only to model some situation we are performing all these things. Okay, supposing, let us take that some tube light manufacturing factory. Okay, we will consider the situation in tube light manufacturing factory. They say that this light will glow for 1,000 hours. Okay, it doesn't mean that every light they have tested. Okay, every light they have put it on working condition and examined that it is working for 1,000 hours. If they have put all the lights on that working condition, we will have nothing to serve our purpose, right? So they perform some calculation and they say that on an average every light is supposed to glow for 1,000 hours. Okay, that is mean. Whereas it is not necessary that all the lights should glow exactly for 1,000 hours. Some will glow for 950 hours, some will glow for 1,000 or 1,025 hours, some will glow for 900 hours, some will glow for 1,075 hours. So these kind of variations or deviations is acceptable when it comes to probability theory. Okay, that is what is happening in reality as well. Okay, so to what extent it can deviate? Okay, so x, supposing x is the actual lifetime of something that we are discussing. Okay, this mu is the average. Okay, we say that it is going to be something like this. Okay, to an extent standard deviation means this can vary to this extent. In general it can vary to this extent. Okay, so probability of happening of this is 1. Okay, suppose if it is exceeding more than standard deviation, the probability is going to be lesser. Okay, these things we will see in the upcoming videos. Now we will work out few problems based on this expectation and mean and variance. If you see here in the question, it is given that probability density function of a random variable which is given to be f of x, which is a plus bx square. Here a and b are unknowns. Okay, in the interval 0 to 1 and it is 0 otherwise, and expectation is given. Now we are asked to find out the values of a and b. Whenever density function is given, we know that integral infinity to minus infinity to infinity, the density function is 1. Okay, and expectation we know it is integral minus infinity to infinity x f of x dx, and that value is given. Okay, you know f of x is a plus bx squared. Just substitute them, perform the integration, you get some expression in a and b. Okay, next substitute in the expectation and perform this integration, you get another expression in a and b. Now that you have a system of two equations with two unknowns, just solve them and you will get the values of a and b, right? Moving further, the next problem here we are dealing with discrete random variable, and some situation is given. So here if you see, the mass has some unknown values, but at every place we have the same c. Okay, now what are the things that we need to find here? We need to find out the value of c. Okay, we know that the total probability is 1, right? So to find the value of c, if we just do this thing equate to 1, okay, you will end up something with 1, sorry, something with c, and that has to be equated with something. So if you just make a sum of all these things, plus 4c equals 1. So from this you can very well find out c is 1. Okay, next, mean. So what should we do? That is x multiplied with this p of x minus 2 multiplied with 0.1 plus minus 1 multiplied with 0.1 plus 0 multiplied with 0.2. If you just do it, you would get zero point 0.8. Okay, in a similar way, here to calculate the variance, this can you can do this as well. That is, once you have the mean, okay, you can subtract it from x, square it and multiply the probability, or you can simply calculate summation x square p of x. Okay, once it is done, you can just do summation x p of x whole square. Okay, so this way also you can very well do it. Or if you want to get this one from this is also possible. All you have to do is to work with something like just take them as common quantity and introduce some just mathematical manipulations you will have to do to get the equivalence. You can work with any of these formulas, right? Okay, this way we can find out the variance. Next, to find probability of x greater than or equals 1, greater than or equals 1. So equals 1 means this quantity, greater than 1 means we have these two possibilities. So we just have to sum all these probabilities, that is going to be 0.6. Okay, next, probability of x smaller than 3, smaller than 3, which means 3 is not included. All these values are smaller than 3. Now that we need to add the probabilities of all these 5 values, that is 0.9. Next, we are asked to find out the probability of minus 1 less than x less than 2. Minus 1, 2. These two are the extremes, but these two are not included. So only these two things. So that is going to be zero point 0.4. Next, we need to find out the distribution function of x. It means what? Cumulative. Minus 2, it is the starting point, that is zero point 0.1 itself. Minus 1, it is the sum of these two quantities. Okay, when you it is the sum of these two quantities. Next, when you come to 0, you will have to find the sum of all these three quantities. So it is the cumulative sum. Like this, you can calculate the distribution function for everything. Okay, now we have another problem which is dealing with continuous random variable. Here if you see, here also we have some unknown quantity k. Of course, the question would be to find out the value of k. So all you have to do is integral x plus 1 upon k. It is from 2 to 4 only. Elsewhere it is 0. Okay, just perform this integration and find out the value of k. Right? Next, f of x. Okay, here you are going to have three different cases. One is when x is smaller than 2, it is 0 of course. Okay, when your x lie between 2 and 4, so what you have to do, it is from 2 to that x, you will have to integrate it. Okay, if it is more than 4, it is 1. Now you are asked to calculate the probability of x greater than or equals to, only from 2 it is starting, so it is going to be the total probability. Okay, mean and variance. How do you do it? Integral x times of x plus 1 upon k from 2 to 4 dx. This gives you the mean. Okay, likewise, just do it as x square and substitute in the formula, you will get the variance. To calculate this probability, it is from 2 to 3.5. You will have to integrate it. That's it. Okay, so if you calculate, you would get some values of this form. That's it. Thank you.